Hi, everybody. Just wanted to take a minute to kind of talk to you a little bit more about position graphs. So this is an extension on your Lesson 4 video. We've been taking a motion map and we've been turning it into a position graph. So I'm just going to really quickly throw together a motion map. That's literally wrong. There we go. I'm going to throw together a motion map for you real quick. Okay, so let's say we are going to start somewhere. Let's start at the reference point, okay? And we'll start by leaving the reference point going in the positive direction with a positive constant velocity, okay? I want to show you how to take this and turn it into a graph, right? So here's our position time graph, okay? So this is very much like your XY axis from math class, where like your x-axis should keep going this way, but we're not going to care about that because time can't be can't be negative. You can't have negative time in this situation. Okay, so this is our graph, and position is going to be on the y. So position or distance, right? And then 0 is here. 0 is going to be our reference point. Okay, so that's the same thing as right here. Okay, so our object is going to start at the reference point. It's going away, right? So we know away, which is the positive direction, with a constant, and we're going to call it, again, positive velocity, right? Velocity is the speed, right? And how that works down here is velocity is the change in position, which if you think about it as a rate of change, that's just the slope of the line, right? So here we're going away at a constant positive velocity. So we're just going to draw a line like this with a constant slope. The slope here, the rise over run, is not changing, okay, for that line. It's the same rise over run the whole time. It's the same slope the whole time during that motion, okay? Now, what if we add a stoppage? Let's add a stoppage really quick, okay? So I'm going to put a stack of dots here. I'm going to get my eraser out, take out this stuff here. So if we erase this and we leave those dots, right, that stack of dots is showing us that this object is waiting. It's stopped, right? What does stopped look like on our position time graph? Well, stopped is a velocity of 0, right? So if our position is staying the same, right, let's say it's like 3 meters away from 0, right, it stays at that point during that whole motion, okay? So if you ever see an object that's stopped, the line should be flat on the position graph because the slope of that line is 0. This is where velocity equals 0. In this case, velocity is positive and constant, okay? So that's all the like pro tips that you'll need. Now, there's one more thing I want you to see. This one's going to be challenging. What happens if the next movement starts off slow and then gets faster? What would you call something that is speeding up? What is it doing? Like if you were speeding up in your car, what would you call that? Because you can call it acceleration. Okay? So acceleration is the change in speed. So I would write this in your notes, these two things, velocity is change in position and acceleration is change in speed. I would put those in your notes, and I might even write down this example just so you can kind of see how it works. So let's talk about this for a second. We're starting with a slow speed, right? And we know that slope on this line has to do with the speed, has to do with the velocity, right? So if our speed is low, we need to have a small slope. So not very steep, right? Imagine you're on a roller coaster and you're just going kind of slow. You want that speed to not be very fast. So we're going to start off kind of slow. Okay. Then we're going to get a little faster. We're going to get a little faster. Then we're going to get a little faster, right? Until we're going really fast. Almost straight up and down is really fast. Why is it really fast? Because your position, your y-axis values, they're changing really fast while your time, your x-axis values, are not changing very much, right? So our total difference in time here is pretty small, but our difference in position is quite intense, even in this little bit here. We've changed a bunch of position in not even a whole second, right? So that's kind of how that works. I just wanted you to understand those couple of things. Now, acceleration can be positive or negative. There's no such thing as deceleration. So let me open a new slide here and just kind of walk you through another example real quick, okay? All right, so let's put together our position time graph. And we know this direction is positive, and this direction is negative. and then on the y is time. Now, what if I've got an object like this, right? What is that object doing? Let's try and describe that. I'm putting that there on purpose. I want you to see that's going to kind of help us with something. So we start off very steep, right? And steep slope equals fast, right? Now, what direction is the line pointing? Is it pointing in the positive direction or the negative direction? That line is pointing in the negative direction. So we know we've got a fast negative velocity. Now, what happens as we get closer to 0 here? As we get near the reference point, we're slowing down, we're slowing down, we're slowing down until we're going very slow, right? We're still negative and slow. But right here at this point, if you see the slope of this line here, this is where the velocity equals 0. Our object is actually stopping just for a second. Stops for like a split second. Okay, I don't know why it says Caitlin Blair there. Sorry, Caitlin Blair. Your name's on the screen. Then we are going to start going again. So as we start speeding up, okay, you're going to see that we're starting with a very slow speed, so slow, but which direction is the arrow pointing? It's pointing up, so slow and positive, and then it's going to become fast and positive, okay? So this is an object that's slowing down and then speeding up. How would you draw this on a motion map? Let's try it. We're starting somewhere very far away from the reference point, right? So that's here. It's this point. Then we are going to be going fast, but getting slower as we go. I should have made that arrow bigger. Yep. Hold on. Let me make the arrows a little bit bigger so that I can try a little bit less. There we go. It's a really big arrow. That's the stuff. And then, yeah. So then we stop. Where did we stop? At the reference point, right? And then we're going to immediately start speeding up, everyone, and going away from the reference point. So that's how that would look as a motion map. I hope that is helpful for you.